I bought this really cute ring the other day, but when I wore it, my finger turned red and itchy. It turns out I'm allergic to a metal in the ring. Gold jewelry doesn't give me this problem, but making the whole ring out of gold would cost a fortune. But there's a cheap and simple solution. Add a thin plating of gold to the outside. Let's talk about how chemistry makes that possible. This is Real Chem. Gold plating is all about controlling the amount of gold we coat on the ring. Just enough to cover it, but not so much that it gets too expensive. We're talking about amounts of gold, which means stoichiometry. But here we add a twist. Instead of just moles of atoms, we'll talk about moles of electrons. That might sound a little odd at first, but once we break it down, you'll see it makes a lot of sense. Let's dive in and connect what we know about stoichiometry to the world of electrochemistry. To plate a layer of gold atoms onto the ring, we start with a solution containing gold 3 ions. But here's the thing. If I just drop the nickel ring into the solution, nothing much happens. I won't get that nice shiny layer of gold I'm hoping for. To make it work, we need to help the process along by applying external electrical energy. That energy encourages the gold atoms to plate onto the surface of the ring. Gold plating works a lot like recharging a battery. In a galvanic cell, electrons naturally flow in the direction they prefer, like from cadmium to nickel in a nickel-cadmium battery. But when we want to recharge it, we have to step in and change things up. Instead of letting the electrons do what they want, we attach the battery to an external power supply. We pay the power company to provide electrical energy in the form of electric current, forcing the electrons to move in the opposite direction. That's how we recharge a battery, and it's also how we plate gold onto a ring. To get a nice, durable layer of gold onto my ring, let's say 0.1 grams of gold atoms onto the surface, I need to turn the ring into an electrode in our electrochemical cell. The current we're buying from the electric company flows into the electrode, and for every 3 electrons that make their way into the ring, we deposit 1 gold atom onto its surface. That's what's happening at the particle level. But what about the bigger picture? If we want to track what's going on a scale we can work with, we need to think in terms of moles. Let's start with the basics, figuring out how many gold atoms we want to deposit on the ring in moles. Since we need 0.1 grams of gold, our first step is to convert that to moles using the molar mass of gold. Now that we know how many moles of gold atoms we're working with, we can determine how many electrons we need. Each gold atom requires 3 electrons to plate onto the ring. So for every mole of gold atoms, we'll need 3 moles of electrons. See? I told you, a mole of electrons would start to make sense. Now that we know how many moles of electrons we need, we hit a practical question. How do we get them? The electric company doesn't sell electricity in moles of electrons. They provide current, which is measured in amps. If they're delivering 1 amp of current, that's equal to 1 coulomb of charge per second. So how do we connect coulombs to moles of electrons? This is where the Faraday constant comes in. Faraday's constant is 96,485 coulombs per mole of electrons. It converts moles of electrons to coulombs. This gives us 145 coulombs of charge needed to plate our 0.1 grams of gold. And if the power company is delivering 1 amp of current equal to 1 coulomb per second, we can use the current like another unit conversion. Converting from 145 coulombs, it'll take 145 seconds to deposit the layer of gold onto the ring. What we've really done here is extend stoichiometry into electrochemistry by adding new conversion factors, moving from moles of gold to moles of electrons, and from moles of electrons to electrical current. Whether it's jewelry or industrial applications, electroplating is a perfect example of how chemistry provides practical and elegant solutions to everyday challenges. like my allergy to cheap rings.